I want to give you a little video about naming and drawing cycloalkanes. This is actually really pretty simple. If you remember about how to name alkanes, then naming cycloalkanes is actually just as easy. In fact, it's probably easier. Now, just to give you an idea about what the difference is, if you look at this guy, 1, 2, 3, 4, 5, 6 carbons, we know that as hexane. All right. And with 6 carbons, there's 3, 5, 7, 9, 11, 14 hydrogens, C6H14. If we look at this guy, this is 6 carbons as well, 1, 2, 3, 4, 5, 6, so it's also hexane, but they're in a ring. And that's what a cycloalkane is. And to let people know that it's in a ring, you just put the prefix cyclo in front of the name. Therefore, 6 carbons in a ring is cyclohexane. 6 carbons. However, on each of these carbons, because each of them has 2 bonds, there's 2 hydrogens. 2 times 6 is 12. So the reason we're doing this is so you can see hexane and cyclohexane are, in fact, different compounds. So the naming convention is slightly different too. This down here is butane, 4 carbons, 10 hydrogens, 4 carbons in a ring, cyclobutane. 2, 4, 6, 8 hydrogens. So again, the number of hydrogens is different in a ring versus in a chain. Okay. So naming these, you just have to put the prefix cyclo in front of the name. Doing all the substituents and all the other stuff, that's pretty much exactly the same as it was before. So if we look at this guy to begin with, what makes naming these guys easier is you have to figure out the biggest ring in the molecule rather than the longest chain. Well, in most cases there's only one ring, and it's pretty evident what size it is. 1, 2, 3, 4, 5, 6. There's 6 carbons, it's hexane, it's in a ring, so therefore its name, the parent name, is cyclohexane. Now what's coming off the cyclohexane? Well, there's this guy, it's a 1 carbon substituent, it's a methyl group, methyl cyclohexane. Now in this case we don't need any numbers here because all these carbons in the ring are the same. So there's no need for us to put 1 methyl cyclohexane. If we have more than 1 substituent on here though, we'd have to know where that substituent is relative to the other one, like we have down here. So look at the size of the ring first. 1, 2, 3, 4, 5. Now 5 carbons is pentane, so in a ring it must be cyclopentane. Alright. And then see what substituents we have here. We've got a 1 carbon substituent and a 2 carbon substituent. That's a methyl group and an ethyl group. So we know we've got methyl and we know we've got ethyl here. Now the only thing that makes these even vaguely complicated is we have to figure out a numbering system, just as we did before. We want our substituent totals to be as low as possible in exactly the same way as we've seen previously. So in that case it makes sense to start counting on a carbon where you have a substituent. For example, you wouldn't start here and go carbon 1, 2, 3, 4 and 5 and have the substituents on 3 and 5. That wouldn't make any sense. You'd start either here or here. Now in this case we have 2 substituents, one that comes alphabetically first. The ethyl comes alphabetically first, so what we usually do is assign that position number 1. Now we do that when we have the positions, the substituents in the same position relative to each other, no matter where we start. So if we started here, 1, 2, and 3, or if we start here, 1, 2, and 3, the numbers are going to be the same. It's just a case of which substituent gets which number. And like I said, the one that comes first alphabetically gets the lowest number. So therefore 1 ethyl and 3 methyl. So can you guys see 1 ethyl, 3 methyl? We're using exactly the same hyphens and commas that we used before. 1 ethyl, 3 methyl, cyclopentane. Now what about going from names to structures? Well, this is just the same thing. Cyclobutane. Now butane means 4, cyclo of course means 4 carbons in a ring. 1, 2, diethyl. So what does that tell you? Well, there's ethyls, di says there's 2 of them, and 1, 2 means they're on carbons 1 and 2, the next carbons to each other. So if we do 1 ethyl group here, The other ethyl group is going to be on the next carbon. It's either up to you as to whether you draw it here or here. It doesn't really matter. But something like that would work just fine. Now what about this one? 4-ethyl 1,1-dimethyl cyclohexane. That one's kind of more involved. But you can see to begin with there's a 6-membered ring because it's hexane and cyclo. Now there's 2 methyl groups here. Now what does it mean when there's 2 numbers that are both the same? Well, that means the substituents are on the same carbon. There's an ethyl group here that's on a different carbon. So I'm just going to say, I'm just going to call this carbon 1 up at the top here. Let's say that's carbon 1. And I'm going to put my 2 methyl groups on there. And I'm going to count round to carbon 4. 1, 2, 3, 4. I don't care whether you count clockwise or counterclockwise. In this case it doesn't matter. You have the ethyl group coming off carbon 4. 4-ethyl 1,1-dimethyl cyclohexane. Remember, the ethyl comes first alphabetically. Alright, now the last thing I want to show you here, I want to see who can figure this one out. Parent ring, of course, is what we've seen before, cyclopentane. That's the easy part. This is a bit more tricky because we've got 2 substituents. But let's take a look at them. 1, 2, 3. What's the name of a 3-carbon substituent? Well, that's propyl. But the issue we have here, this is a 3-carbon substituent too. 1, 2, 3. But can you see this substituent is clearly not the same as this one, because here, when you come off the carbon, when you come off the ring, carbons 1, 2, 3 go in a line. This is just a normal propyl group. This guy, that's not the case. This goes carbon 1 and 2, but carbon 3 is not connected to it. It's connected to 1. It's still a 3-carbon group, though. It's still propyl, but I hope you guys can understand there's got to be a different way to describe this than this, otherwise nobody would know what you're talking about. So this guy is actually an isomer of this, and so what happens is the prefix iso goes in front of this. And this is the one case where a prefix for something becomes part of the name when you're alphabetizing. And that's needed because otherwise, if you didn't include this in alphabetization, this would still be propyl and propyl, so you wouldn't know which one would come first. So isopropyl comes before propyl, simply because I comes before P. Now, can you guys see, let me choose a different colored pen. Can you guys see that these 2 substituents are on carbons 1 and 3 relative to each other? Alright, so let me just write on. We know isopropyl comes first, because I comes before P. I'm leaving a space for the numbers here, because we're going to figure out what those are. The numbers are going to be 1 and 3, but the question is which has 3 and which has 1. Well, when we have the situation like we had before, and this could be 3 and 1 or 3 and 1, you always put the lowest number with the one that comes first alphabetically, which in this case is iso. Isopropyl, so therefore 1 isopropyl, 3 propyl, cyclopentane. So that's how you name cycloalkanes. It's really not that difficult.